Hello everyone. In this video, I'm going to talk about a natural language toolkit where we'll understand some of the techniques like word tokenization, sentence tokenization, and regular expression. Natural language toolkit. In short, we call it as a NLTK. It's one of the important toolkit in NLP. So with which we will be able to do a lot of pre-processing, right? So we'll see that how we can do a pre-processing with the help of this tool. And first and foremost, you need to install an NLTK with a pip install NLTK. So then only you'll be able to import this NLTK module, all right? So the first and foremost thing is here we will understand tokenization. Right. So when I say tokenization, it's there are two things. First one is a word tokenization, and another one is a sentence tokenization. All right. So as you can see here, sentence tokenization, right? One second, sentence tokenization, and we have one more word tokenization. So what does this mean? Suppose say that I have a paragraph here, as you can see, right? So I have a paragraph, and if I say word tokenization, so what it does, it will segregate word by word. India is one word, and at the same time, this open parenthesis, right? So that bracket you see, that is also a word here, right? So when I say word, it means that it is going to treat this as a altogether different word, right? Hindi is one word, colon is one word, Bharat is one word. So basically it is going to split this entire paragraph into words, word by word, word by word. That is nothing but word tokenization. And when I say sentence tokenization, so it is going to split this paragraph into sentences. So as you can see, if we clear this slide, so here it starts from here and it will end somewhere, here. This is going to be one sentence. And again, the next sentence will start from here and will end at a word, right? So there is a full stop here. So when I say full stop, it doesn't mean that always it will stop at the next full stop. So it does all those, interpretation. So where that full stop is appearing. So it is smart enough to understand whether the sentence is completed or still it is going to continue. So depending upon the word where you have, placed and where this full stop or the period comes, so it does the interpretation with respect to the word, and then it will split into sentence, right? So again, this is one of the sentence. All right. So wherever you see here, I would say somewhere here, right? Maybe, here, right? Sorry about that. So this is basically a sentence tokenization. So what we'll do, we'll execute and see that how things will work here. All right. So how to import the word token, right? So word tokenize. So very simple. So first you need to import NLTK after installing. So then from NLTK.tokenize, you have to import word underscore tokenize, right? So that's how we'll import the word tokenization module here. And here I have a simple text. I'm learning natural language processing, right? So that I'm going to store in this particular variable, right? So now I'm going to call this word tokenize. Then I will pass this text, right? So it will take this text and it will split into word by word, word by word. All right, let's execute. Yes, I have imported the tool here and assigning this text to the text variable, and I'm applying a word tokenize and printing it. As you can see, I is one word, YAM is one word. Similarly, learning, natural, and things like that. Right? So this is a simple word tokenization example here. So let's see how sentence tokenization works. So what I will do, first I will start with the simple text, right? So let me, okay, so let's execute this. Let's execute this. And how to import a sentence tokenize. So same like a word tokenize, from NLTK.tokenize, import sent underscore tokenize. And here I'm passing this text. I'm storing this text into variable again, text. And this time I'm going to use the sentence underscore tokenize or sent underscore tokenize and passing this text, right? Let me execute. If I print that, you can see that, so there is a period here, right? There is a full stop, but sentence tokenization understands that, okay, so I should not make a sentence up to here only, just because I have a period there, right? It will understand that whether this statement is going to complete or not, right? So it sees that there is some number and it assumes that, okay, this is not the end of the sentence. So it will take entire this thing and make a one sentence. This is one sentence. And here, good job, Mr. Bajaj, right? Here also we have a dot, but still it did not end the sentence here itself. It knows that it is something like a name, referring a name, right? So it makes a sentence considering entire text here, all this entire data. All right. So that's how the sentence tokenization works. So you can pass a big paragraph, still it will be able to make a sentence by sentence, depending upon where this period, and at the same time, by interpreting whether that period is end of the sentence, becoming end of the sentence, or there is a something else that is attached to that dot. All right. That's a sentence tokenization. Now let's talk about the regular expressions. So why do we need to understand these regular expressions? The regular expression, when I say irregular expression, in our language, right, wherever you see an article or any kind of a book or wherever, right? So we come across all these regular expressions, right? So now whenever I want to process this language for any reason, so these regular expressions will not give any meaning, right? So they don't give any meaning. So why do we need to have that regular expressions, right? So whenever we process a natural language, right? So we always try to remove these regular expressions because they don't carry any value. Let's understand how to deal these regular expressions, right? Same again, NLTK.tokenize. I will import regexp underscore tokenize, right? Regexp underscore tokenize. You can import this way. And there are many other tools available with respect to regular expressions. This is not the only tool that available to deal with the language. There are many other tools that you will get, right? So that also you can make use of and try to deal with this work, apply the different tools to the language. All right. So here we are using regexp underscore tokenize because it is available in the NLTK. All right. And I have this text, a big text where we can see the caps and small letter and the numbers and some of the expressions and things like that. This is a sample text and I'm assigning into this particular variable text text. Okay, so now let's see that how I will be able to print only the particular data and how I can able to filter the data based on some condition. So whenever I use regexp underscore tokenize, right? So I'm going to call this and I have to pass my text. This is my text, right? So then I'm saying that comma, so is a square bracket A to Z. So it means that it starts from A, small a, and ends at Z, small z. So this dash makes sure that it starts from A and up to Z. It's not only A and Z, it's A to Z. So whatever the characters comes between A to Z, including both A and Z. So, and after that, any data, right? After that, any data with the small cases. So I want to include only those data. Remaining all data I want to filter, right? So this is how I will be able to mention, right? So let's execute. So you can see here, NLP is basically in caps, so that we did not include here. So start from is, fun, and in the can, C is a capital or a uppercase. So that C is excluded here. We have only am. All right. Similarly, we have a lion, AM, and things like that, dollar symbol. So we, right? So all those data will be filtered, right? Only the lowercase data will be printed. All right. So that is how you can interpret this. And there is something like if you observe this, but there is something a can't, right? So how it is printing? Can and T. That doesn't sound good, right? So how do I handle this type of data? So that we'll see, all right? So how do I mention my code here so that I will be able to print this can't, only one go, right? Let's see that. So there I'm going to mention this extra quote. As you can see this extra quote. Otherwise, everything is going to be same, starting from A to Z. And if there is any don't, can't, wouldn't, couldn't, things like that. So if you want to include that entire word, then you can mention this extra quote after Z, right? So after that, any data comes, plus means any data comes, you have to include. Otherwise, exp underscore tokenize and text. So remaining everything is same, right? Let's see. Right now you can see that can't is completely in one word, right? It's not split like earlier, can and T are not separate words here. So both are same word. So that is how you can, code your code here. I mean, this extra code you need to code, all right? So now if you want the caps only, capital letters or the uppercase letters, you just need to change from lowercase a to z to the uppercase a to z. Very simple. Let's execute. So in our language, in our text, we have only few, uppercase letters. So NLP is 1, C, and W, and 11, AM, right? AM basically. So and W. So only you can see that data here because it's A to Z. Remaining everything, all the data will be filtered. So then everything in one line, if you want everything in one line, so you just need to mention slash A to Z and quote. If you print that, you will see everything in one line. It is just like you're printing your own text, nothing else, right? You're just printing your own text. You don't need to use this in that case, right? But if you're using and still you can go ahead and do that one, right? Now, there is something you can see here, caret, right? This symbol caret that you can, that you will find on your keyboard at number 6, right? So regex underscore tokenize text, and I have a caret. What does this mean? So it means that not equal to, right? Which is not equal to small a to small z. So every data other than a to z will be printed. All right, let's execute. As you can see, all those small data is eliminated. right? Other than that, everything is printed, right? Wherever it is the small cases data available, so there it has just placed empty, right? Spaces, right? So that is one way. And now printing only the numbers, yes, 0 to 9, plus anything start from 0 to 9, and after that any number will be printed. I'm sure you would have got the idea here, 11, right? Because that is the only one data which is in terms of numbers, right? So without number, yes, you have to use this caret. With and without. Without is basically a caret here. So except 11, everything will be printed, right? So used to have here 11 a.m. Now we don't have that now. And if you want to eliminate only the dollar symbol, yes, everything is same. Just you need to mention the dollar. You want to print only dollar, yes, you can print the dollar sign. All right. So this is how I will be able to make use of regular expression, right? So we'll see more of such techniques. And in this video, that's all. Thank you for watching this video and keep learning. Thank you.